Hello, welcome. Let's try to solve another Leetcode problem. 1411, number of ways to paint n times 3 grid. Yeah, so for this problem, we are giving n times 3 grid, and we want to paint each cell of the grid with exactly one of the 3 colors. So let's just use an example. Yeah, because here for the example, this is n equal to 1. Since it is a 1 times 3 grid, so as we know, there are going to be 12 different cases, so we're going to return a 12. Yeah, but this value of n can be really big. So the maximum of n can be 5,000. Yeah, so if it is a 5,000, definitely we cannot use something brute force to solve it. Even if we use brute force, it's going to be really difficult. Yeah, so the idea is that we might use some dynamic programming to solve it. So the idea is that we're going to have 2 different cases for each of the color. Yeah. So first of all, let me use ABA as the first case. Yeah, so this means in this combination, for each row, there are going to be 2 different colors, as we know A and B. So for example, A is red, B is yellow. So it's going to be 2 different colors. So another case, we're going to call it ABC. It means for each row, we're going to have 3 different colors with ABC. Yeah. Now, if the first row is fixed, so for example, it can be ABC, ABA, or ABC. So what about the second row? Yeah. So for this ABC, so for this ABA, so we're gonna call it maybe case 1, and for this ABC, we're gonna call it case 2. Yeah. So if the previous layer is case 1, yeah, it means it is 2 colors. So what's gonna be the next layer? What's gonna be the current layer? Yeah. So it also have 2 cases. It can have a case with case 1. Yeah. If it is a case 1, it means it has 2 colors. So how many different cases? If it has 2 colors, maybe it can have the next color. It's gonna be BAB. Of course, this is possible. Yeah, because it's a different color. BAB. This is a BA. This is AB. This is a AB. Yeah. Or maybe it can have some different colors. Maybe C, but it cannot be B because this is a B. Yeah. Maybe it is a CAC is also okay. Yeah. Now let's just check. Can it be something like BCB? Yes, it can. Yeah, you know, BCB is also different. It can have something like BCB. Yeah. So can it have something like BCBC? Because this is B, this means that it's not possible. Yeah. So for the next layer, so what about it is case 2? Yeah, this means it's gonna have 3 different colors. Let's just check. Currently it is ABA. So what about we prepare like BAC? So this is possible. Yeah. So what about we prepare like BCA? It's not possible. Maybe we're gonna continue to check. What about CAB? So this is also possible, right? Yeah. As you know, CAB is possible. So what about CBA? Because this is B, so that means it is not possible. Yeah. So if the current layer is the first case, for the if the previous layer is the first case, so for the current layer, it can be if it is the first case, it can be 3 combinations, and if it is the second case, it's gonna have 2 combinations. Yeah. Now let's just check this one. If the previous layer is ABC, so what about if we have the first case? It means 2 colors. What can we have? Maybe we're gonna have try to check with B, A, B. Of course, this is possible. And what about B, C, B? Yeah, let's just check. We're gonna use B, C, and B. Yeah. So of course, this is also possible, right? Yeah. So now, what about we just try to use C? What about CAC? That is not possible. So what about C, B, C? That is not possible because this is C. Yeah, so that means that it's gonna have two different cases. Yeah, let's just continue to check. So what about it is case 2? So if it is case 2, it means I'm gonna have three different colors. So I'm gonna try to check with B, C, A. So this is okay. So what about I'm gonna try B, A, C? This is not okay because this is a C. So let's just continue. What about C, A, B? So this is also okay. So what about I'm gonna try C, B, A? So C, B, A, because in the middle this is B, this is B, it's not possible. Yeah. So now we get to the conclusion. So if it is case 2 for the previous layer, so the current layer, if we choose to use the case 1, it means the two colors, we have two different cases. And if it is still the case 2, I mean with three different colors, so it's gonna have two combinations. Yeah. So according to this kind of idea, we can write the formula by using the DFS with memorization to solve the problem. Yeah, because the DP is always dependent on the previous state, and by using the previous state, we can always get the current state. And then this gonna be the and all those areas, this gonna be the previous state. And then according to the previous state, we can always get the current state until we get to the end of the row, and we're gonna find the final result. It's gonna be how many combinations. So this is just the DFS idea with memorization to solve the problem. Yeah. Now let's just continue. Maybe we can write the formula. Yeah. So now let's just write the formula. Why not? I can not use the. Yeah, I'm not sure, but definitely I cannot use the previous previous Blackboard writings to use it, but I think basically I can write it. So let's just continue. So we're gonna use DFS. Inside the DFS, I'm gonna prepare the current row and prepare the permutation. So the permutation gonna be inside. It can be 0 or 1. So this I is just the index, and the permutation can be 0 or 1. Yeah, 0 or 1 just means two different cases. And 0, I'm gonna use 0 to define it as something like ABC. And for 1, yeah, let me just write it here. ABC. And for 1, I'm gonna use something like ABA. Yeah. According to this kind of combination, basically I can solve the problem. Yeah. Now I'm going to check that if I equal to the length of the how many rows. So I'm gonna return 1. It means I find one case. Yeah. Let me first maybe return the DFS. So the DFS is gonna be starting from 0 with a -1. Because for the first row, definitely I need to check all cases, because for the first row there's no dependency. Yeah, so I'm gonna give a -1 from the beginning, and then it's gonna be 0 and 1 for this permutation. From beginning, I also need to have a case because I need to use memorization with DFS to solve the problem. Yeah. Now I need to check this I. So if I equal to 0, so this means it is the first row. So for the first row, it's going to be 6 times DFS, because for the first row, no matter it is ABC or ABA, how many cases. So for ABC, it's going to be 6 cases. Yeah, it's just a permutation of ABC. And for ABA, how many cases? It's going to have 6 cases, because it can be ABA or ACA or BAC or BCA or CA. Yeah, I just cannot code all of them, but you should know about that. So ABA, it can have ACA, and similarly for B and C. So it's gonna be 6 cases. So inside the DFS, it's gonna be I plus 1 with a 0 plus DFS I plus 1. It means the next row with a sign 1. It means it's gonna have the 0 case and 1 case, ABC case or ABA case. Yeah. Now, else I'm gonna check the permutation, because for this 0 I assign a permutation of 0 and 1, so I'm gonna check the permutation. If the permutation equal to 0, so this means it is a case of ABC. Yeah, so if it is a case of ABC, and definitely I can return 2 times DFS with I plus 1 with a 0 plus DFS I plus 1 with a 1, and finally I need to modular the mod. So let me prepare a mod, because the number can be really big, and the final answer gonna be modular a mod. This mod is 10 to the power of 9 plus 7. Yeah, so for here, let me modular the mod. Yeah. So this case is just for if it is ABC. So if it is ABC for the next one, I have 2 cases. I can have something like BCA. Yeah, BCA, and I can also have something like CAB. Yeah, I can have CAB, but I cannot have CBA. Yeah, so that means 2 times DFS, I plus 1 with 0. So what about choose a case 1? It means I can have something like, yeah, let me just write it. I can have something like BAC is not possible, but BCA is possible. Yeah, I can also have something like, yeah, so this is for the case 0. So I can have like something like BCA, or I can have something like CAB. Yeah, so there are 2 cases. So now let me just check if it is a case 1, how many cases. Yeah, so if it is case 1, I can have something like not A. I can have something like B, A, B. Yeah, that is possible. So what about B, C, B? That is also possible. So what about C, A, C? This is not possible, right? Yeah, and CBC not possible, but we can have a BAB and BCB. So it's gonna be 2 times the DFS with case 0 and case 1. Yeah, and similarly, we're gonna check the else case. It means P equal to 1. So we're gonna return. So for the case 0, 2 times the DFS with I plus 1 with 0 plus DFS I plus 1 with 1 modular the mod. Yeah. So for this case, basically I forget, but let's just check. I forget which one is 2, which one is 3, but let's just have a check. So this is for case 1. So this means if I have something for case 1 ABA, so what I gonna have? So if I choose to use case 0 means ABC, so I can have something like BCA, not possible. Yeah. What about BAC? I can have something like BAC, it is possible. So what about I can have something like CAB? This is also possible, but I cannot have CBA. Yeah. So there are 2 cases. So what about, there are 2 cases of this case 0. So what about case 1? So for case 1, I can, so this is ABC, I can have something like B, A, and B. It's okay. I can have something like B, C, B. This is also okay. So what about I'm gonna choose C? I can have something like CAB. This is also okay, and I can have something like CBA, but that is not. Yeah, I got something wrong. This is BCB. This should be CAC. But if I choose CAC, this is ABA. This is CAC. This is okay, but I cannot choose CBC because in the middle there's a B, and this is also a B. Yeah. So this means there are 3 cases of case 1. That means my conclusion is okay. 3 times DFS, I plus 1 with 1. Yeah. Actually, this is the entire code. We just need to get some conclusion from the mathematics, from the mathematics, we have the combination and permutation. So by the permutation and combination, we get the conclusion of this DFS formula, and by this kind of formula, we can get the final result. Now let me just run it to check. As you can see, it works. Now let me just submit it. As you can see, it works, and it's pretty fast because the time complexity is I times p. So I is the length, is how many rows. It's gonna be 5,000, and this p gonna be just 2 because it can only have 0 and 1. Even this is a -1, it is okay. So the final time complexity gonna be 1 times 10 to the power of 4. Yeah. So that is why it is so fast. Thank you for watching. See you next time.